turn on projector. And there we go. It was really exciting to see the three of you who came Friday, but I'm glad y'all came, and hopefully you've been able to catch up what we did. Had a good time, and got most of 1.9 completed, but not all. And Carla's here, right? Okay. Okay. Anyone else come in since I called her off? Okay. Okay. And the last thing we did was the problem on the PowerPoint, and then as we finished, I realized that wasn't the problem that was in the book. So we will do the books problem today first thing, and then we'll move on from there. But before we do, let me give you just a couple of announcements, things to watch out for. It's good we did it last Friday, because that's my last full Friday to be available for 3 in a row now. This coming Friday, I've got a dermatology appointment at the Kirkland Clinic in Southside Birmingham. So I'll be there. It starts at 9:15. Now, what I haven't decided, and I've got to talk with my boss about it, to see if he wants me to come in. I'm usually there before 8, but I'll have to leave by 8:45 to be at the appointment by 9:15. So I don't know if it's worthwhile for me to go in for 45 minutes, then leave. I'll be coming back after the appointment. I just don't know what time that'll be over. Hopefully I'll be through by 10:15 and back on campus by 10:45. But I don't know that for sure. That will depend on how backed up they get and how slow they are and how much they want to do. It's just a exam type thing, so it shouldn't be too bad. So this Friday, maybe on the Birmingham campus from 8 to 8:45, and I'll probably be there from, say, 11 to 12, maybe a little later. But the middle part of that, I definitely will not be. Okay. Then next Friday, I've been assigned to go down to an articulation meeting in Mobile. Okay. That means I'm going to have to leave home about 7 in the morning, drive to Mobile, hopefully get there before noon. The meeting is 3 hours, so that's 4 to 5 hours of driving for a 3-hour meeting, and then drive back another 4 to 5 hours. It sounds pretty worthwhile to me, and I had resisted saying I would go because it sounded like so much stuff, but then I was told, yep, you're supposed to go. So I'm going. And then the third Friday from now, I have an eye appointment, and that's just across the street here at Birmingham West, UAB West. Oh, Birmingham West. UAB West Hospital. I thought it was going to be Eye Foundation, but he said, no, he's at Birmingham West on this Friday. I said, well, that's right across from where I work, so I'll be there. That appointment's 8:15, so I'll come here, go to my appointment, and then either stay here or go back to Birmingham, depending on what the needs are. All right. I think I saw Jayla come in, right? Yeah. Okay. Now I've got to find you. I know you're in. There you are. Okay. And one other. Yeah. Okay. Q came in. Okay. Did anyone else come in while I was yakking? Okay. I'm always yakking. Okay. So, any questions before we get started today? And by the way, by those 3 Fridays, it's spring break almost, so I will be here, as far as I know, the Friday before spring break, unless that's that one that I'll be at the eye doctor. But then spring break Friday, of course, I won't be here. Okay. I hope y'all won't be either. Okay. Okay. Any questions? We should finish 1.9 today, easily, and then that means we'll be ready for the test on Chapter 1, which covers 1.4 to 1.9. 4, 5, and 6 were covered in the on the quiz. They'll also be on the test, and 7, 8, and 9 will be on the test as well. You will not have been quizzed on that, but you will. Those will be on the test. Now, this is roughly, the first page will be roughly the first 3 sections, a lot like the quiz, not the same questions, but covering the same material. And the second page will be more the last 3 sections. There may be one of the last 3 on the bottom of the first page. I don't remember. It's been a while since I made it up. So, but that's about it. We'll try to get started as soon as y'all get here. If there are any questions right when you come in, I'll try to answer those quickly. But I want to give you at least an hour to work on the test. So come. Now, also, you cannot take the test unless you've turned in your quiz. Unless, of course, you ask me nicely to give you a 0 on the quiz. And then I have to do it if you ask me nicely. And whoops, I can't write with that pen. Yeah, I got it. Thank you. Okay. Then I'll have to give you the 0 because you asked nicely, but I don't want to. So please get your quizzes in before Thursday morning, or by Thursday morning. If you get them in sooner, I can get them graded and you can see what you may have missed. I really hate it when I have to mark things wrong twice, on the quiz and then on the test, because you didn't get the quiz in to find out that you were doing it wrong, and then you do it wrong on the test as well. So please get them in to me sometime today or tomorrow, preferably, okay? And just to remind you, I'll be on campus today until, well, close to 6. Usually I'm here till 6, but I've got to meet with an instructor on the Birmingham campus by 6:30, so I have to leave right at or a little before 6. So try to get to me before 6 today. And then Wednesday, I'm here from 8 in the morning. And I've got office hours 8 to 10. That's a great time to bring them by, okay? And then I'm in class from basically 10 o'clock until 3:45. And then I have to leave almost immediately, go to Birmingham East Campus to do a physics class that starts at 4:30. So I have to leave very soon after 3:45, as soon as I can get away. So, yes. Yes, it looks like it if we finish the chapter today. Oh, man, this sounds sad. No, I'm sorry. Yeah, when could you? Okay, let me give you my choices. If you want to come early, okay, Wednesday I have office hours 8 to 10, so that's a good time. Thursday I have almost no office hours, and Friday, I was just telling them before you came in, I have a doctor's appointment at 9:15 at the Kirkland Clinic, so I don't know if I'll be going to the Birmingham West Campus or not beforehand, but if so, I'll only be there 8 to 8:45, so that's not a lot of time. But I'll be going back after the dermatology appointment's over with, so hopefully there by 10:45 or 11. So if you wanted to come there, that's a possibility. Other than that, Monday I've got 8 to 10 and 3:45 to 6. So Monday's a good day too. Okay. Monday, okay. And let's see. Got it. Kendria, right? Kendria? Mayfair, right? Okay. Good deal. Anyone else come in since I called roll? Okay, I know y'all are tired of hearing that. Y'all want to get to algebra, so let's do it. Okay. Again, we covered this problem. If you've listened to the YouTube video, you'll recognize we did that problem. And then I glanced down after we had completed it and realized that wasn't example 6 in the book. They didn't update the slides set to match the book in the last edition. And I updated the slide set, used the most current, and they still hadn't gotten it done. So here's the new example 6. Let me get my pen set up. Okay. f of x. All right. Okay. Anyone else come in since I called roll? Okay. All right. This is example 6 from your text, not the one on the slide set. F of x is equal to 5 minus x divided by 3x plus 2. Okay. It says find the inverse function of this graph. Okay. Now, this graph has a few more problems than that one did. That's putting it mildly. Okay. So what we have to do with this one, even though we haven't done this, this is what I'm going to do now, is actually coming from section 2.6 that we will get to one of these days, okay? And why they put this problem here, not sure, but they showed you what the graph was and then said find the inverse function of it, okay? Let me show you how to get the graph. You don't need to know this for the test. The next part you do need to know, but for the test, you don't need to know this part. Okay, how do we graph something like this? Well, there's 4 major things we look for. X-intercept, Y-intercept, vertical asymptotes, and horizontal asymptotes. Now, we haven't even touched on the asymptotes yet. You should know what intercepts are. I'll tell you what the asymptotes are. Okay. Which one you want to try first? Pick one of those 4. Anybody? Second? X-intercept. What's true about the x-intercept? Y is equal to 0, right? X-intercept is where it intercepts the x-axis, intercepts the function, the line, and that's where the x-axis is where y is equal to 0. So you say, well, where's a y? I don't see a y here. What is your y? F of x. So set this equal to 0. Now there's a couple ways you can proceed from here, and we've done this before, earlier, I think on the first half of the chapter. How's the only way that this is called a rational expression, by the way. It's a ratio of 2 polynomials. Rational expression. How's the only way that a rational expression, or let's call it a fractional form, can ever be 0? Only way a fraction can ever be 0. Say again? Okay, if the denominator, actually, if the denominator is 0, what does that mean? Undefined. You can never divide by 0. Now, since she went there by mistake, okay, but Thomas got here on purpose, okay. Let me find you. All right. Oh. One thing I was supposed to do, I think probably last week, I didn't see the email until after the week was basically over, at least for this class. I was supposed to call roll only according to the official roll, okay, which means only paid students. Of course, I have it in my roll book, and I didn't print off that. But earlier, back when we did no-shows, I found out that in a few classes, a few students, very few, were not on the official roll. And I think I've spoken to everyone that was not. If you had any issue with payment, be sure you get that taken care of now. I mean, as soon as possible, because you may be removed from the roll permanently, and you don't want that to happen. You sometimes can argue your way back, but it's better get it taken care of now. All right, so since Krista was insisting on making the denominator 0, but we said the denominator can never be 0, that means that's your definition for a vertical asymptote. Where that denominator is 0, the function can never be there, and that's going to be that. Now, where is that denominator 0? I like to actually write it this way. 3x plus 2, that's your denominator. is not equal to 0. How do you solve that inequality? Say again? Subtract 2 from both sides. Very good. That gives you 3x, this adds to 0, cannot equal negative 2. And now what? Divide by 3. And that tells you x cannot equal negative 2/3. Okay, so I'm going to proceed to start to draw the graph. Okay? I'll tick off a few points here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5, 6, 7. And negative 1, 2, 3, 4. Okay. Now, where is x 2/3? Negative 2/3. It's right over here. But you know, since the graph can't get out of there, since the graph can't touch there, get out of there. Okay. Since the graph can't touch there, I'm going to put it in red. Negative 2/3 is just short of negative 1, so it's going to be here. Vertical asymptote, the function can never, ever, ever touch that. It can approach it, but not touch it. So there's your vertical asymptote. We took care of that first because Krista made us, okay? Now, what do we say about the x-intercept? That's where y is equal to 0. Now, how can you make a fraction 0? What's the only way for that fraction to be 0? If what?
Multiply by 0.
Multiply by 0? Oh boy, that removes all meaning from the equation whatsoever, because everything becomes 0. Let's not do that ever, okay? We don't want to divide by 0. We don't want to multiply by 0, okay? How can we determine when is a fraction ever 0? In general, any fractional form. We know the denominator can't be 0. When the numerator is 0, 0 over 53,483 and 2/3 is still 0, okay? If that numerator is 0, the whole value is 0. So what would make the numerator 0? 5. Ooh, I'm still red. Okay, get out of here. Say again? Okay, I've got to get my... There, here we go. Back to black. Okay. 5 minus x equals 0. And what do you say do?
I said if x equals 5.
Okay. X equals 5. That would be where your x-intercept is. 1, 2, 3, 4, 5. Right there it is. That point. 5, 0. Okay? We've done x-intercept. We've done vertical asymptote. What do you want to do next? There's y-intercept and there's horizontal asymptote left. Which you want to do? Y-intercept. What's true about a y-intercept? Say again? X equals 0, because y-intercept is where the function intercepts the y-axis. And what about the y-axis? X is always 0 on the y-axis. Always. So you say x equals 0. I think even I can do that. So, where I'll do it right here. F of 0 is equal to 5 minus 0 over 3 times 0 plus 2. I really didn't have to write all that. Y'all probably could have done it in your head. What is your value of f of 0? When x is 0 and 3 times 0 is 0. So what are you left with? 5 over 2. Okay? And here's Tara. All right. Has anyone else come in since I called roll? You didn't hear me acknowledge you. Okay. Sometimes I get carried away and don't recognize it. Okay. So, when x equals 0, f is always, what is f? F of x? Y. The y is 5/2. Where is 5/2? Come on. Where is 5 halves? What is value is 5 halves on the number line? Second, 2.5, 2.5, 1, 2, and it's positive, so it's right there. So there's the y-intercept. Okay? All right, got 2 points, x-intercept, y-intercept. We got one vertical asymptote. Now, what in the world is a horizontal asymptote? What a horizontal asymptote is where the function goes when it gets very large, either negatively or positively. Where is the function heading? Okay? Sometimes it will be toward an infinity, positive or negative. Other times it will be toward a value. And what you deal with here, because when x is getting quite large, positive or negative, the 5s and the 2s, they really lose their meaning. Everything's tied up in the x term. Okay? So what we do here is look at the ratio of the leading terms. Now this one isn't written in correct order, but I can still do it. Okay? The ratio of minus x to 3x. Okay? That's a minus sign in there. Okay? What is that ratio of minus x to 3x? The ratio. X is divide out, right? And you're left with minus 1 over 3. There's your horizontal asymptote. Minus 1/3. Okay? Now, I'm going to put this in red too. There is a little bit of a difference between vertical and horizontal asymptotes, and I'll tell you in a minute. Ooh, bless you. Okay. Negative 1/3 is down here, so I'm going to extend this line this way and that way. Okay. Now the difference between a vertical and a horizontal asymptote. A vertical asymptote, the function can never touch it because the denominator can never be 0. A horizontal asymptote, the function can touch it, it can cross it. The deal is it has to be approaching it as x gets very large, positively or negatively. Okay? Well, I think we see where this thing is heading, because basically what we've done here, our two asymptotes have formed a new coordinate system almost. So, in this quadrant of the new system, of the red system, we already have 2 points. And it has to be approaching, whoa, I should have meant to get to my 0. Okay. It's approaching the vertical asymptote this way and approaching the horizontal asymptote this way. I may not have drawn it exactly right, but it's pretty close. Okay? Now, we got to figure out where it is in the other side. Okay? So we need to do a test point. What is a typical test point? X equal, give me something that might work. -1. Sounds like a really good idea. How did you think of that? Okay. So, let's do f of -1. Go back to our original function, so let me erase some of my ugliness up here. Not all my ugliness. I can't get rid of all that. Okay. A little bit of it. Okay. So let's plug in a -1 there and see what value we get. What would that be? Numerator would be? Numerator would be? Say again? Okay, break it down for me. 5 minus a -1, think again now, okay, divided by?
3.
Whoa, I lost my 3, didn't I? When I erased the other part? Let me get that back in there. Okay, let me get that out of there. I lost my 3. Okay, 3x plus 2. Okay, and you said 3 times -1 plus 2. Okay, let's figure what that is. What's your numerator? 6. What's your denominator? -1. So that's going to be a -6. With Quinn here, it's still a -6. Okay. All right. Good deal. Has anyone else walked in since I called roll when I didn't see you? Okay. All right. So when X is negative 1, your Y is negative 6, somewhere way down here. So let me give a guess here. It's approaching negative infinity. Okay? And guess what? It typically doesn't cross, though it could cross the horizontal axis, so basically it's going to be doing this number. This is called a hyperbola, by the way. You don't need to know that for your test or anything, but that's what it is. It's a curve this way and a curve that way. This one's not curved enough. I wish I had drawn it better. But that's the general idea. Okay? Now, why did we do all that? Because the first thing, what it said to do, is find the inverse of this function. And what's the first thing we need to know before we do the inverse of a function? 1-to-1. Is it a 1-to-1 function? And what does it mean to be a 1-to-1 function? Has to pass a test. The what? What test? Horizontal line test, of course. Does this pass it? Yes. Even though these things are getting close to horizontal, they never quite reach it. They're always approaching that line, but never getting closer. Same thing over here, but still, it is. So this passes the horizontal line test everywhere. Everywhere it passes the horizontal line test. So therefore, this is a 1-to-1 function. The one problem is it's not defined here at x equal negative 2/3. Right here, remember? Now, it's okay. It's still a 1-to-1 function, but it's just not, doesn't have a value there. All right. So we've done the first, use a horizontal line test to decide whether f has an inverse function. Yes, it does. Okay? That's why we did all that graphing. Boo-hiss. Just for that. All right. Second step. This is in your book on that same page as the example. Now, what I'm going to do is erase everything but the function. The only reason we did the graph is to answer question 1. Does it pass a horizontal line test? Yes, it does. It is a 1-to-1 function. It does have an inverse. Okay? Now, let me also say this. Has an inverse at every value except x equal negative 2/3. And when you do the inverse functions, what do? You flip your x's and y's. So therefore, the inverse is not going to have a value at y is equal to negative 2/3. So just stand by for that, because everything has to flip. So let's erase all this stuff, except the original function. Okay? And there it is. I often wondered how this looks at home. It must be really weird. This things start disappearing on you. You can get rid of this. Okay. One of these days we'll be through. I almost think it was better to have erased the whole screen and then rewritten it. But I was just being obstinate. Okay. All right. Think that's done. Okay. All that was for step 1. Passes the horizontal line test. Is a 1-to-1 function. So the next rule, what do? These are really simple steps. What is your f of x? Y. Replace that and just say y is equal to 5 minus x over 3x plus 2. That was easy, wasn't it? First step was really complicated. You don't always have to graph it. The one we did, if you listen to the YouTube video, talk a way around it, in the one that was in the book. This one we almost had to graph. Okay? Second, change the f of x to y. That was really easy. Next one's pretty easy too. What is it? Say again? X's and y's. Flip them. So this becomes an x is equal to 5 minus y over 3y, and that's pretty much a plus 2. I don't know why it looks so bad, but it is. Okay? There's the step. There's the first part of step 3. I do that 3 and then 4. They cram 2 things in the 3. And what's the second thing they cram in the 3 I count as a new step? because it's really important. Pretty exciting, huh? Second? I can't hear you. Okay, we're going to solve for y. So we multiply both sides by that denominator, which is 3y plus 2, and this side by 3y plus 2. Okay, now what does the new left-hand side become? Multiply it out. Oh, wait. Yeah, I think we still got to do that. You get 3xy plus 2x is equal to 5 minus y. All right. Now, what is our goal here? Solve for y. So that means you need to get all the y's on one side and all the non-y's on the other side, right? Not that anyone's non-y's, but okay. So what would you do first? Do what? I would leave 5 where it is. That's a non-y. Let's move the other one. Add y to both sides. Okay, we got all our y's together now, but we still got a non-y over here on the left. Right? Left, right? Okay. What non-y do you see? 2x. We want that on the other side, so we subtract 2x. Okay? And these will add to 0 then. So what are we left with? 3xy plus y is equal to 5 minus 2x, right? Don't forget the 5 up there. Okay? Now, you've gotten all the y's together, but you don't have them isolated. What can you do to isolate that y? Second? Factor. Good idea. Factor out the y, and what are you left with? 3x plus 1. Perfect. All right. Help me. Bree, got it. Thank you. All right, got it. Anyone else come in since I called roll? Okay. All right, so there's the left-hand side. What we're doing is finding the inverse of a function, not this one, this one. It's in the book, example 6 on page 88. And we're in the middle of the second part of their step 3, which is, I like to call step 4. So over here, that's the left-hand side. This is still 5 minus 2x. Now what do we do? One more step to isolate that y. Get that y completely by itself. Divide both sides by 3x plus 1. All right. We've gotten the y isolated. The next step is really easy too. What is it? What is it? Just like up here when you change the f of x to y, when you flipped your y's, now you're not dealing with the same y anymore. It's a different y. So what is that going to be? F inverse of x. So f inverse of x is equal to 5 minus 2x over 3x plus 1. All right. That is replace the y with f inverse of x in the new equation. All right. That was easy. So first step, if you have to graph, sometimes that may take a little effort. Okay? Next step, change the f of x and y, really easy. Next step, flipping the x and y, really easy. Next, and I put this as a separate step, solving for y, that took a little more work. But it still was easy, just took more effort. Okay? Once you got it solved for y, then change that y back to f inverse. Not f inverse. Okay? So, we've gotten that far. That's the first, I call them 5, they call them 4 steps. The fifth one, though, this is where a time consumer, okay? And also a space consumer, and since I don't have much space, I'm going to erase again all my work here except the answers. Okay, so I'm going to erase this. That's how we got there. If you weren't here to see it, it will be on the YouTube video. So be sure you go and watch it. Okay. Make sure I erase everything except that final answer. Okay. So here's your F, there's your F inverse. Now what's the last step say to do? Verify these are indeed inverses of each other. You may have made a mistake. Oh, heaven forbid. But it could have happened. So how do you verify? How do you know if two functions are inverses of each other? Does the word composition ring a bell? This isn't English class, by the way. Say again? Yeah. Okay, no, you do the composition of F and F inverse. You got to do it both ways, though. You first do F of F inverse, or it doesn't matter which you do first. I just happen to write this first, and see what that is. Okay, what are we hoping it is? If they are inverses of each other, what is F of inverse? F of F inverse? X. Okay? And then if that works, then you do F inverse of F. And if that is an inverse function, what is that? X. Okay, so let's see if this produces an X. Well, what is F of F inverse? What do we plug in first? Inverse. So F of, and plug in what F inverse is. 5 minus 2x over 3x plus 1. Okay. Now, what we have now is the F function operating on this thing. Not on x, but on this thing. Well, up here, the F function is operating on x. So everywhere you see an x up here, you put this thing in its place. Ugh. Okay, so that would be F. Well, let's not write the F again. Let's just plug it in. Okay. I'm going to come back here because I might need the room. Okay. So, F is operating on this thing. So what does the F function start with? 5. So 5 minus that thing. The x there now becomes this. So this becomes 5 minus 2x over 3x plus 1. Okay? That's your numerator divided by what's in your denominator. Your F function has a 3 times your x, which this is what you plug in then. 5 minus 2x over 3x plus 1. And then your F does what else? Adds 2 to it. Right? You see what's happened there? Everywhere you saw an x up here, you put this in its place. You got 5 minus this, divided by 3 times this, plus 2. Okay? Now we got to work with that. I've got itchy nose, must be going to have company. Okay. How do you simplify a fairly complicated looking fractional form like this? Back in earlier text, you probably called it a complex fraction. I don't like that name because complex to me denotes has some imaginary number in it somewhere. This doesn't. But it is pretty complex. I like to call them complicated fractions. No one else does. And besides, you say, well, are all fractions complicated? No, but okay. So how do you solve something like that? Say again? Yes, and what is your least common denominator? In this case, it's your only denominator. What is it? 3x plus 1. What do you do with it? Multiply both the numerator and the denominator by 3x plus 1. Which means you're going to multiply each term in the numerator and the denominator. So I'm going to do that as well. 3x plus 1 times that, and a 3x plus 1 times this. Each term is multiplied by that. I just distributed it at the same time. All right. Now this one got a lot nastier. Not nastier, just different, more complicated. If you multiply that out, what do you get? 5 times 3x plus 1. Help me. 15x plus 5. Very good. Minus, now I've got to put my parentheses in here. Notice what happens here. This 3x plus 1, multiplying by that, eliminates your denominator. That's why we multiplied by it. Okay? And you're left with a 5 minus 2x. Okay. That parentheses is important here, wherever it is here, because that minus sign has got to negate everything. Okay, in your denominator, the good news over here is the 3x plus 1 goes out, and then you're left with a 3 times 5 minus 2x. So what does that yield when you multiply that out? Say again? A little bit. 15. Okay, 15 minus 6x. 6x, no, 6x. Okay. Then we got a plus 2 times that, and that would be plus 6x plus 2. All right. Now we got to clear those parentheses up here, which is 15x plus 5. And when you clear that parentheses, what does that become? Minus 5 plus, did you say plus? Oh, I'm sorry. I can't hear well. Plus 2x over. Okay, now let's simplify this. Minus 6x plus 6x, that goes to 0. You're left with a 5 plus 2 is 15 plus 2 is 17. Well, let's see what we got in the numerator. The plus 5 and minus 5 add to 0. And what do you have left? 17x, 15x plus 2x is 17x over 17, and guess what that is? X. Yeah. Okay. We got what we were hoping for. Take the function of its inverse, you ought to get an x. We did. But are we through? No, not quite. Okay. The next part is to do the inverse of the function. So unfortunately, but you see, one reason I'm doing this, to give you practice taking inverses, composing two functions, because we only hit it a little bit, and I want to make sure you are highly exposed to it, so it'll be contagious and you'll get infected with how to do inverse functions. Okay? I should have asked if I needed to leave this any longer, but I've already erased too much. Oh, I could have left it. Well, no, it's not. Okay. So, the first step was taking f of f inverse. We did that, complete. So what's the next step? Anybody? A little louder? Just a reverse of what we just did. F inverse of f of x. First time we did f of f inverse, this time we do f inverse of f. To see if they really are, yes?
So do we have to check every time whether it is...
Okay. All right. I was afraid someone would ask the question. I should have known it would be you. Okay, never mind. Okay. Basically, I know there's one question on the test that says show this or so. That one you better show me, because that's what the question is. The rest of them mostly are going to say, what is? Now, you give me the answer. If it's right, it's right. If it's wrong, it's wrong. If you show the work and how you got that, number one, if you did do it wrong, you'll probably find out it's wrong and get it right then. Or I can give more partial credit even if you don't get it right. Okay? So, the one that says, show that thus and so is true, you better show it all. Okay? On the others, I said, give me, say, the inverse of thus and so. That's all I'm looking for. Okay? But, this is how you do it, and this is how you make sure you got the right answer. So if you want to make sure you got the right answer, yeah, do it. But if you want to say, well, I'm willing to bank so many points on this, so yeah, I'll take the bet. Okay.
So what about time?
What's that? Time. That's exactly what I was going to say next. So what I would do if I were taking the test, I'd try to get everything done and then do a lot of checking and proving and that kind of stuff later. That's how I would take tests, by the way. So let's do this one. But I want you to know how to do this, okay? So how do we do this? What's your first step? What do you plug in where? Yeah, you plug in F, the innermost thing. So this is going to be F inverse of, and what is your F? It's right there. 5 minus x over 3x plus 2. Okay. Now, what does the F inverse function tell you to do? Start with the number. Help me. What is the F inverse function? It takes whatever is inside the parentheses, starts with the number 5, subtracts 2 times what's in the parentheses, that's your numerator, divide that by 3 times what's in the parentheses plus 1. So you tell me what to write here for F inverse acting on this thing. 5 minus 2 times 5 minus x over 3x plus 2, that's what's in the parentheses, divided by 3 times what's in the parentheses, which is 5 minus x over 3x plus 2. What else? Plus 1. Got it. How do you simplify something like that? Yeah, same way. Least common denominator, and the only denominator is 3x plus 2. So let's multiply this by 3x plus 2. Let's multiply this by 3x plus 2. Let's multiply this by 3x plus 2. And multiply this by 3x plus 2. Everything, numerator and denominator, by that. Okay, what's that first term in the numerator going to be? 5 times 3x is 15x plus 10. Now we have another minus sign, minus 2 times. Okay, here, your 3x plus 2's go away, thank goodness. And we could have multiplied this. You want to go on and do it? Is this doing skipping too many steps here? Okay. Multiplying this times this. Can we do that right now? Okay, minus 2 times 5 would be minus 10. So let me get my eraser and make that a minus 10. And minus 2 times minus x is plus 2x. Okay, divided by, down here, the 3x plus 2 divides out that 3x plus 2. And can you multiply that through? 15 minus 3x plus 3x plus 2. All right. Now, what you notice you can deal with in the numerator. I'm going to sit down so y'all can see a little better. Yes, you can subtract out the 10s. They add to 0. And the denominator, the minus 3x plus 3x, adds to 0. What do you have left in the numerator? 17x. That sounds familiar. Over 17. And sure enough, that's equal to x. Ding, ding, ding. We've got it. Okay? Now I have to stand up. That's harder than sitting down. Okay. Sorry. Okay. So now we've finished everything. We've verified that these are indeed inverses of each other because f of f inverse is x and f inverse of x is x. Both of them are true. Therefore, this is the inverse function of that. Can't do that by inspection anymore, can we? That was sort of a waste of effort there. I mean, when they're really simple, you can. Notice you still have a lot of the same things, but they're just twisted around differently, okay? So don't even try to guess. Do the work. All right, that was example 6. I think we're ready for example 7. Are there any questions on 6? People still writing? Got it? All right. Let's see. Oh, yeah. We've already done, check your YouTube video for example 6 from the book. So we're, hey, wait a minute. Wait a minute. Ah, I hadn't realized this. All right. Even though they had the problem wrong, they're doing the right one. So now we are going to see this done. And the first thing they did was graph it. Okay? Now, a couple things they didn't do. They did get the horizontal asymptote right at 2.5. Now, each one of these spaces, no. Oh, that's not even the same problem, is it? No, it is. No, that's it.
It's the same one.
But it's 2.5. They put this at 2. They got it wrong. Oh, no. This is just showing it's a horizontal line test pass. They didn't put in any asymptotes because we hadn't done them yet. This is how they graph, and they just said, voila, here's how they graph. I showed you how they did. They got the x-intercept here, and this was actually 2.5, so it's right there. Now, the y-intercept, 2.5. The x-intercept was 5, and it's right there, okay? The horizontal asymptote was at, minus 1/3, and that was right there. They didn't draw it in. Vertical asymptote was at minus 2/3, and that was right here. They didn't draw that in. But they do show that, sure enough, this is a one-to-one function because no horizontal line intersects more than once, ever, okay, ever. So that's the first step. Does it pass the horizontal line test, making it one-to-one? Yes, it did. Passes horizontal line test, so you know it's a one-to-one function. It does have an inverse. Now we got to find it. So we write the function down again. Good for them, okay? What's the next step? This is review. What's the next step? What is f of x? Y. You write down the y instead of f of x. That was so easy, right? What's the next step? Flip them. Flip the x's and y's. So now we have x is equal to 5 minus y over 3y plus 2. Okay? Good for that. Now what do we do? Solve for y. What's your first step to do that? Multiply both sides by your denominator, which is 3x plus 2. And that gives you x times 3x plus 2 is equal to y, 5 minus y, because multiplying this with 3x plus 2 is going to wipe that out. Okay? Now you got to clear your parentheses. So that'll be a 15y plus 10 is equal to 5 minus, no, 15. Where am I? Where's my head here? 3xy plus 2x is equal to 5 minus y. And there it is. 3xy plus 2x is equal to 5 minus y. Distributing. Okay? Now what do we want to do? Second? Not yet. Ooh, really fast. You're on the draw here. No. Got to get all the y's together. And all the non-y's on the other side. So that's going to be adding a y to both sides and subtracting a 2x from both sides. And that, sure enough, is what they did. 3xy plus y is equal to 5 minus 2x. Everybody see that step? Getting all your y's on one side, all your non-y's on the other side. Now what do we do? I think you told me. Somebody. Factor out the y. That's isolating the y. Factor the y out, and that left you a 3x plus 1 is equal to, and on the other side, 5 minus 2x. And now what? Divide by 3x plus 1. And sure enough, that gave us, okay. Next step, easy one. What's that new y now? Undoing what we did before. That's your F inverse. All right, that's that. You have finished finding it. The rest of it is verifying it. Check. Notice how the authors do this. That's so nice. Check the F inverse. F of F inverse is equal to x, and the F inverse of x is equal to of F is equal to x, without showing you to do it. They just said, "You do it." Done. Okay, we've done it. All right, that was example 6. Let's do example 7. All right, example 7 is find the inverse function of f of x is equal to the square root of 2x minus 3. What do you have to do first? Second? Not yet. Okay? Not yet. You're jumping 2 steps ahead.
No, it said equal to.
That's you 1 step ahead. Second? Okay, that you're still 1 step ahead. What you got to do first?
Make sure it's 1-to-1.
Make sure it's 1-to-1. How do we do that? Second? Yeah, unfortunately, most of the time it's graphing. But I think we can sort of talk our way through it, kind of, can't we? Okay. Now, here's how I'm going to talk my way through it. What's the parent function of that thing? Parent function. Square root of simplest one. X, square root of x. How would that look? I'm going to do this in a different color. What color would you like me to do that? Red. Okay. Square root of x looks like this, right? Half a sleeping parabola. We know that, don't we? All right. Now, what are we doing with that? We are, this isn't quite as nice as I was hoping it would be, your x, you're doing everything to the x. One thing you're doing to the x, you're multiplying by 2, which is going to be a horizontal shrink. But then the other thing you're doing to the x is subtracting 3, which shifts which way? And to the right. Remember, everything's backwards in x. So, basically, you have something that looks like this. Ooh, I should be in black now. Something that looks like the horizontal shrink is going to bunch it up some. So I think it's going to look like that. Oops, I went the wrong way. Sorry about that. Yeah, it goes to the right. You're pointing me right. Sorry about that. That's a minus 3, so it doesn't go minus, it goes plus. Sorry about that. Okay. Oh, wait. Just went to erase. Why is it not erasing? Oh, because I'm not hitting the buttons right. There we go. All right, sorry. The horizontal shrink is going to bunch it up some, and then you're doing 3 spaces this way, so it's going to be, ooh, that's too much. Something like that. Okay. That's pretty ugly, but hopefully it'll work. Okay. Now, I think we can look at that and say, yeah, that's a 1-to-1 function. Okay? That's never reaching an asymptote. This is probably a little too bunched up there, but whatever. Okay. So, passes the horizontal line test. So it is a 1-to-1 function. All right. Now, I'm going to leave that for now, because we are going to need it later. Okay, get rid of that and make this a little bit better here, something like that. Okay, now, what's the next thing we're going to do? F of x to y. All right, we made sure it was a horizontal line test passed its one-to-one function. Change the x to y. Y is equal to, you tell me, square root of 2x minus 3. Right? Next. Exchange them. X is equal to the square root of 2y minus 3. And what are we wanting to do now? Solve for y. So what do we got to do first? We got to free that y. Free Willy, okay? Say again? How do we do that? Say again? How? Squaring it. Square both sides. That makes this at x squared, and that makes this at 2y minus 3. Perfect. Now what? We're wanting to solve for y. Add 3 to both sides. Okay, that gives us that x squared plus 3 is equal to 2y. And then what do we do? Divide both sides by 2. And you got it. Okay? Now, what's the next step? What is that new y? F inverse of x. Change that y back to not f, because this was f. Change it to f inverse. It's equal to x squared plus 3 divided by 2. Okay. Now, let's think through this a little bit. Okay? What this is, the parent function of this thing is a squaring function. I'm going to go back to red again, if that's okay. If I can get it to go back to red. And the squaring function would look like this, right? A parabola, right? But we were limited here because all your x's here had to be greater than or equal to did I draw that right? No, I didn't. Okay. I sort of botched that up. I moved too much. Okay. Sorry, I'm having a bad day today. Okay. What we needed to do at the very beginning here was, I'm going to erase this because all that effort I went to draw it and it's not quite right. Okay. What we had to do was say, what's our domain here? You got a square root. What has to be true about everything under a square root? Positive. Got to be greater than or equal to 0. So we know that oh, I didn't mean that. Okay. 2x plus 3 greater than or equal to 0. Right? Okay. Now, let's solve that inequality. And what would that be? How do you do that? Subtract 3 from both sides. And you get 2x. This adds a 0 is greater than or equal to negative 3. And then you do what? That's a minus 3, not a plus 3. Goodness gracious, what's wrong today? Okay. Yuck. That's, you add 3 to both sides, and that, okay. Okay, 2x is greater than 3, and then you do what? Divide by 2. Does that change the sign of the inequality? No, because you're multiplying and dividing by a positive number. Does it change the sign? So you get x greater than or equal to 3/2, which is 1.5. So this is where that function goes, like that. Okay? It's all taken care of there. Okay. Now, your parent function for this is x squared. Now what we're going to do here is, we're going to write it this way. X squared over 2 plus 3/2, which would be 1/2 x squared plus 3/2. Okay? Which the 1/2 x squared is going to be a vertical shrink, because that's less than 1, and you're going up 3/2, which is up 1.5. Right there. Now, okay. Whoa! What happened there? There we go. Okay. Now, we knew, number 1, that x has to be greater than this, but also we know here y, your f of x, is always positive, isn't it? Always positive. You can't have it down here. Why? Why wouldn't this function have continued here? Why didn't you fill in the parabola here? It wouldn't be a function. Failed the vertical line test. You can't have that. So therefore, when we do the inverse here, we can't have this. That would fail the horizontal line test. So we only do the right-hand side of this, and we move it up to 2/3. And we squish it a little this way, and there's what we got. Okay? So I'm going to take the parent function out of there, because we don't need it anymore. I'll even take out that little red line there. And this is what we've got. Now, notice what other thing is, it's a perfect reflection across the identity function. You don't need to come down here because it's not there. Sure enough, that is a reflection across the identity function. That is the inverse. Okay. Now, is it close to time? It can't be, can it? It is. Oh, there, watch. Oh my goodness. Close. Now, we didn't have time to do the checking it. The f of f inverse and f of f inverse of f. But just like the book did, we can say, we'll leave that to the student. Verify this. They don't do it either, but you can if you want to. There is a checkpoint, by the way, after every one of these, so please do those. Homework exercises. Well, let's do vocabulary first, real quickly. We've got a couple minutes. If f of f inverse and, if f of g of x and g of f of x both equal x, then the function g is the blank function of the function f. Inverse function, perfect. Number 2, the inverse function of f is denoted by f with a -1, f inverse, exactly. The domain of f is the blank of f inverse. Domain of f is the range of f inverse. Okay? Perfect. Okay? And the blank of f inverse is a range of f. Domain of f inverse is a range of f. They just flip-flop. Okay? Number 4, the graphs of f and f inverse are a reflection of each other in the line. What is that line? What is it? That's not a horizontal line. It's the line y is equal to x, the identity function. Okay? Okay? And number 5, the function f is blank when each value of the dependent variable corresponds to exactly one value of the independent value. Each value of the dependent variable is equal corresponds to one value of the independent variable. Each corresponds to 1. 1 to 1. Hey, how'd you guess that? Okay, good deal. Okay, it's 1 to 1. Okay. And number 6, a graphical test for the existence of the inverse function of f is the blank line test. Horizontal line test. Great. Homework exercises. Any of the odds, 7 through 13. They're all at Calc Chat. 9's at Calc View. Either 15 or 17. They're both at Calc Chat. 15's at Calc View. Do 19. It's at Calc Chat. Any of the odds, 21 to 31. They're all at Calc Chat. 23's at Calc View. Do 33. It's at Calc Chat. 35's at Calc Chat. 37 or 39 is at Calc Chat. 41 or 43 are at Calc Chat. 41's at Calc View. Any of the odds 45 to 53, they're all at Calc Chat. 45's at Calc View. Any of the odds 55 to 69, they're all at Calc Chat. 61's at Calc View. 71 to 77, they're all at Calc Chat. 79 to 83, they're all at Calc Chat. 85 or 87, they're all both at Calc Chat. 89, do that one if you can. True False 91, try to do that one. They both should be at Calc Chat. 93 should be at Calc Chat. 95 is a proof. If you want to do it, you can. It should be at Calc Chat. You can think about doing 97. If there's anything there, you can do it at Calc Chat, and you can think about doing 99 too. Okay, one-to-one function representation, you can do 101 if you want. We're not doing 1.10. Another good thing you can look at if you need a few more exercises to think about, at the end of the chapter there is a great chapter summary. And let me say this too. Remember on your test, every test, including the final exam, you can bring with you a formula and equation sheet. Anything you want to write down on a piece of paper would be great to bring with you during the test, and you can use it so you don't have to memorize things. Okay? This might be a good source of things to put on your formula and equation sheet. The chapter summary. Only 1.4 through 1.9. You don't need to do 1, 1, 2, and 3 or 110. Then you've got review exercises here. They're also at calcchat.com, the odd numbers. So you can do any of those. You don't need to worry with 1.1, 2, or 3. 1.4 starts on page 107. You can do the odds of each of that set of groups. 1.5, 1.6, 1.7, 1.8, and 1.9. You don't need to worry about 110. And then another thing you could look at is the chapter test. Now, I think in the back of the book, they may have all the answers for the review and the chapter test, but at Calc Chat, they only have odd numbers. So do whichever you want. Odd numbers certainly would be good. Don't worry about the ones from 1, 1, and 2, and 3, or 110. And next time, we'll have the test. Thank you. Get your quizzes in to me today or tomorrow if you can. But you have to turn them in by test day. Okay? Thursday morning. Oh, excellent. Excellent. Thank you.
Can I do one about an article I read?
About what?
I read.
Second?
Can I do one for an article I read?
Yes, yes. Okay, you mean for the physical science? Yeah. If it has something to do with physical science, fantastic. All right, good deal.
I did the checkpoint, but I did not get the answer.
You did what? Checkpoint. Did you go to the LarsonPrecalculus.com?
The one we did.
Okay.
Inverse.
Yeah. But you see, there's a checkpoint. You can go audio, video solutions of that or at LarsonPrecalculus.com. Free website. Okay? If you still can't understand how they got it,
so this is the checkpoint, or this is the checkpoint?
This is the checkpoint.
It install here?
And this one, then here's the checkpoint.
No, what is the solution for this?
What's that?
Where is the solution for this?
The solution is at LarsonPrecalculus.com.
Okay.
Really good website.
But how I can find?
Just type it in. You know how to do it.
And what are the sections on test?
What's the what?
Sections on test?
1, 4, 5, 6, 7, 8, 9.
6.
Yeah, 6 sections. The first 3 were quizzed on. The last 3 weren't quizzed on, but they're all on
Together.
Yeah.
And
probably a little heavier on the last 3, but not too much.
And do we have graph on test?
Yes, at least 1, maybe 2. I don't remember, but this author is going to have a graph on everything. You know.
And do we have to check on graph on test for this?
Do you have to what?
Check on graph, like 1-to-1 or something.
I asked for answers. Give me the answers. You can do it any way you want to. Good idea to do this to get it right, but just like you're saying, you have to judge how much time you got.
So what if we ran out of time?
Don't worry about that. Usually if you run out of time, I'm going to give you more time, but we'll have to work it out so you can do that.
And how many questions are there?
It's about twice what the test was. The quiz was. The quiz was 10. This is about 20. It may be a few more, a few less, but around 20.
Okay, and we can write anything on the sheet.
On the paper, scratch paper, formula and equation sheet you bring, and I'll have graph paper if you prefer your own, bring your own graph paper.
Can we type it in computer and bring?
What, your formula and equation sheet? Absolutely, whatever you want to do. Anything you can get on a piece of paper. front and back even.
Thank you, sir.
Regular sheet, not.
And we're going for the field trip, right?
No, you didn't see the email and the announcement. The guy at Sanford, I've got to retire. Wait.